Welcome, welcome to Scholar Opportunity Nexus. And in today's series of video, we'll be solving questions on resolution of vectors. We've already learned what a resolution of vectors is and the principles behind it. So we are coming to solve some question on it. And with our first question, um, and I'm reading the question. An airplane is flying with a velocity of 200 kilometers per hour at an angle of 40 degrees. Determine the horizontal at 40 degrees above the horizontal due east. Determine the aeroplane's effective velocity components in the eastward and upward direction. So in solving this kind of question, they said an airplane is moving at a velocity of this, that's 200 kilometers per second, and it's above the horizontal due east 40 degrees. So in this case, we are using cardinal points, so it's best for us to represent it with cardinal points. We have north, south, west, and east. So they said it's moving due, it's above the horizontal at 40 degrees. So taking, meaning the vector is somewhere here and it's above it 40 degrees. So this is, let's say the velocity is, so here is v. So you should find the eastward and upward direction. So the upward direction will be due north, in the eastward direction that's due east. So the upward direction will be the vertical component when we extrapolate or we draw it. It's the same thing. Will be the vertical component and the eastward will be the horizontal component. So let's bring this into a right angle triangle since that's what we see from it. So this is a right angle triangle and the angle is above 40 degrees and we have V, that's 200 kilometers per hour. Now we have to find Vy and Vx. Now, since the angle is lying on the horizontal part, we can see that using SOHCAHTOA, cos would be what we can use here because here would be the adjacent and here would be the hypotenuse. So you know that cos of the angle, that's 40 degrees, is equal to adjacent Vx over 200. So Vx will be equal to 200 cos of 40 degrees. And then for Vy, so for Vy2, we can see that that's the vertical component. And the special trigonometric quantity that we'll use here is the sine. So we have sine of the angle 40 is equal to Vy over 200. So Vy is equal to 200 sine 40. Now solving it, let's solve this. Solving this, we get Vx, that's 200 cos 40 to be. We have 200 cos 40, that's 153.2 kilometers per hour. And our Vy would be 200 sine of 40, that's 128.56 kilometers per hour. So we see that this is our vertical component Vy and horizontal component. And using Pythagoras theorem, if you add these two vectors, that's using the vector form. So using Pythagoras theorem, when you add these two, you get your actual vector. That's the 200 meters kilometers per hour. So it's just sometimes you just have to look at the question. They just try twisting it. They don't give it to you directly. So you have to get, or if possible, you have to draw. You have to draw. They are telling you, get the parameters down and solve. So let's go to the next question. So for the next question says that an aeroplane. Okay, I think it's the same thing. So taking the next question, let's read it. A force of 50 newtons is applied to push a box at an angle of 70 degrees from the horizontal. Find the effective horizontal push and the vertical lift component of this force. So in solving this question, we can draw, or the best thing to do is to illustrate it with a diagram. So this is the box is lying on the ground, and we have a force of 50 degrees. The 50 newtons is applied to push it. So the force is applied. So this is the force applied to it. It's at an angle of 70 degrees, meaning here is 70 degrees. Find the effective horizontal push. So the effective horizontal push, that's the push along the side. And the push, you see, it's inclined, so there will be a vertical push too. It's being raised. It's being raised like this. So you can see we have this in the invisible vertical part, the horizontal push. So basically, they are just trying to let us find the vertical component. So this is Fy and Fx, and this is F, and this is F. So in solving this, we can see that it's also a right angle triangle. Right angle triangle. Here is Fy, here is Fx, and here is F. And it's at 70 degrees. So what will we do again? We'll still use what the SOHCAHTOA to find this. And since it's still on the horizontal, you see that our cos of 70 degrees will be equal to K, that's Fx, the angle K over F. And for the sine of 70 degrees will be Fy all on F. So now in solving this, we see that we have so Fx would be equal to F cos of 70 degrees, which is 50 cos 70, and Fy will be equal to F sine 70, which is 50 sine 70. So for this, we get, solving it, 50 cos 70. 50 cos 70 will be 17.1 newtons. and 50 sine 70. You use calculator to just do this quickly. You get 46.9 newtons. So you see that 46.9 squared plus. So again, you see that when you sum this up, you get, let's just sum it up to prove it. Let's say we are finding, assuming we are given the horizontal and vertical part. See that we'll have 17.1 squared plus 46.9 squared. And when you solve that, you get 49.9, which is approximately 50. So the Pythagoras law holds over here, even when you are trying to find a vector that was given to you, when you break the horizontal and the vertical parts. Yeah. So this is another way of solving this. Let's look at another type of question involving resolution of vectors. So this is our last question, and it says a force vector acts at an angle of 40 degrees above the horizontal. The vertical component of this force, Fy, is 30 newtons. Determine the magnitude of the F, that's the force, in its horizontal component. So in our first two questions, we were given the force itself. We were asked to find the horizontal and the vertical component. But in this case, you see that we're not given the magnitude of the force, we're just given the direction of it and also one component of it. So in this, you still use Pythagoras theorem. See that drawing our right angle triangle, we have our force to be F, our vector rather to be F. Our vector is a force too. And it said it's inclined or is above the horizontal. So this is the horizontal. We have Fx 40 degrees and Fy was giving us 30 newtons. Now we are trying to find F. Trying to find F. We know the Fy and we already know that to find the vertical part of the or vertical component of a vector, we use the sine identity. That's the sine of an angle. So the sine of the angle, that's 40 degrees. It's Fy over F itself. So now that we are trying to find F, we just no, we just divide or we just cross multiply. You see that we get F to be equal to, we just change the position. So Fy sine 40 of Fy is 30 and the angle that's 40. So we just do this and do a simple calculation. That would be sine of 40. So our angle, our main force or vector is 46.6 newtons. We are asked to find the horizontal component too. So in finding the horizontal component, you do the same thing by, you know that cos of the angle, that's 40, is equal to the horizontal component all over the hypotenuse, that's the force. So over here, our Fx will be equal to F cos 40 and our F was 46.6. So 46.6 cos of 40, 46.6 cos. using calculator, you get 35.7 newtons. I think I didn't bring the newtons for this. Okay, I brought it. So yes, it's something very easy to solve. First, one thing is you get your parameters down. After getting your parameters down, you draw or you illustrate. It's very important to illustrate when solving physics questions. It will help you like get um, an easy approach or a very quick approach when solving. See, so you have to get a diagram, get your parameters, and just use mathematics or relations to solve this. Thank you very much for watching this video, and I hope to see you in our other videos.